Question 11. Which of the following series shows the element in order of increasing the melting point? So when we move across the period, the melting point increases for first four elements and then start to decrease. And as we go down the group, the melting point decreases because the size of the positive ion is smaller, so weaker attraction, the melting point will be smaller for metals. So which one is there? Lithium, sodium, potassium is down the group, so that is wrong. Aluminium, silicon, phosphorus. So like when we have aluminium group 3, then silicon group 4, so like they have tendency to form long chain compounds. And then after that phosphorus, so it will increase from aluminium to silicon, and then from silicon to phosphorus there are simple molecular substance, so it decreases, so it cannot be B. Sodium, magnesium, aluminium. So sodium, magnesium, aluminium, so sodium is group 1, magnesium group 2, aluminium group 3. The size of the positive ion in the lattice decreases and the charge increases, so that's why the melting point will increase. So C is the right answer. Then consider the reaction. So hydrogen plus iodine gives hydrogen iodide. The enthalpy change is minus 90. The bond energy for hydrogen and hydrogen iodide are given. It can be deduced, the bond energy. So how to work out the bond energy? We have the formula, the bond breaking energy minus bond forming energy is equals to energy change or enthalpy change. The bond which we are breaking, hydrogen-hydrogen bond we are breaking, and iodine-iodine. And bonds which are formed, hydrogen iodide, and how many of them are formed? 2 of them. So enthalpy change is minus 9. The bond breaking energy, hydrogen 436, plus iodine we don't know, so we say X, minus the bond forming energy, hydrogen iodide 298, but because there are 2 bonds, so this will be multiplied by 2. So we'll simplify 298 multiplied by 2. It will be 596. And this is 436 plus X, and this is minus 9. So this will be minus 9 plus 596 minus 436, that is equals to X. So 596 minus 436 minus 9. So this will give us 151. So the bond energy for iodine is 151. Is it clear, this question? So it's like an IGCSE question in which you work out the bond breaking and bond forming energy. What is the systematic name for the hydrocarbon? So how to know the systematic name? First thing is select the longest carbon chain. So if I select one, like 1, 2, 3, 4, 5. So this is not, or I select 1, 2, 3, 4, 5. Or I select 1, 2, 3, 4, 5. Or I can select 1, 2, 3, 4, 5 and 6. So this makes the longest chain. Or it can be like this. It does not make difference. But 6 carbon atoms, longest chain, I can select 6 carbon atom. Then numbering should start from nearest branch. So if I number from here 1, 2, 3, because these are the branches. So numbering should start from the nearest branch. So I should start numbering from here 1, 2, 3, 4, 5, 6. So second position and fourth position we have branches. So it is 2, 2 and 4. So 2, 2, 4 and 3 branches are there, identical branches. That's why we call trimethyl, and 6 carbon atoms. So it is hexane. So D is the right answer for this. So whenever you name a hydrocarbon or any organic compound, the first step is select the longest carbon chain, and the numbering should start from the nearest branch, or you can also say a functional group. Is it clear, this question? Then which compound has EZ isomer? To be EZ isomer, the carbon which is having a double bond should have a different branches. So butadiene 1, 2, 3, 4, and butadiene means double bond with the first. So this will have hydrogen, this will have hydrogen and then two carbon. So this cannot be a geometrical isomer. Why? Because two identical groups are attached to a carbon which is having a double bond, so it cannot have a geometrical isomer. When we check for butadiene, butadiene means double bond with the second and third carbon, between the second and third. So this will have CH3 and H will be there. This will have H and then CH3. So two different groups are attached, like here CH3 and H. So they can change their position in CH3 and H. So this can exhibit a geometrical isomer. 1,2-dichloroethene, oh sorry, 1,1-dichloroethene cannot. Why? Because 1,1 means first position we have two chlorine attached. So it cannot have a geometrical isomer because identical groups. Then 2-methyl-butene. So butene is there and 2-methyl. So second position there is also a methyl group attached. So this cannot exhibit a geometrical isomer. Why? Because the two methyl groups are there. So if identical groups, they will not show a geometrical isomer. So the carbon, which compound has an empirical formula for its molecular formula? So compound which is having basically the same empirical and molecular formula. So 1, 2, 3, 4, 5 carbon. So C5, and because it's a cyclic alkane have the same general formula as alkene. So C5H10. So its empirical formula will be CH2. It does not have same empirical and molecular. For this 1, 2, 3, 4, 5. So C5 and 2 hydrogen are removed, H8. 2, 4, 6, 7 and 8 will be there. So the question is, which compound has an empirical formula different from its molecular formula? So here different from empirical and molecular formulas are different from each other. So A will be the answer. But why not B, C or D? Because C5H8 you cannot further simplify, it remains C5H8. Here 1, 2, 3, 4, 5. So C5H12, this will remain C5H12. We cannot further simplify. Here 1, 2, 3, 4, 5. So that is also C5H12 and it will remain C5H12. But A will be like C5H10 will be the molecular formula and empirical formula will be CH2. Which reagent react with propene to form this compound? So diol is formed. How diol is formed? When potassium manganate, acidified potassium manganate reacted with alkene, it will form diol. That's why D is the right answer. So to convert alkene into diol, we use acidified potassium manganate. Propene react with hydrogen bromide, the mixture of 1 bromo and 2 bromo to form. So propene is there. There will be major and the minor product, because what might happen if you have a propene, prop means 3 carbon and first carbon is having a double bond. This will be CH2, this will be CH and this will be CH3 reacted with HBr hydrogen bromide. So what are the possibilities? Maybe hydrogen added to first or bromine added to second, or opposite can happen. Majority of the product, major product, hydrogen added towards side where hydrogen are more. That will be major product. And the minor product, so the major product will be CH3, CHBr and then CH3. And the minor product will be CH2, Br and then CH2 and then CH3. So two products will be formed. So it will produce a mixture of 1 bromopropane and 2 bromopropane. Then copolymer are formed from two different monomers. Like two different monomers, two different types of monomers react to form these copolymers. The repeat units of the copolymers are shown. This copolymer is formed from ethene. Like how to identify, just break the two carbon atoms so you can identify. So one of the molecule is ethene and the other molecule is here hydrogen, CH3, H and H. So what is this compound? 1, 2, 3 and 3 carbon and propene will be there. So B will be the right answer. Is it clear how we work out the monomers from this copolymer? Copolymer here means like two different types of alkenes join to form a long chain compound. Is it clear, this one? So this was these were the MCQs from June 2017.